Welcome back. Let's cover exception handling. What is an exception? So Java throws an exception when something stops the flow of the program. For example, if you ask a user for an integer, but they give the letter P. So here's some code that does just that. We have a scanner is equal to new scanner. This just allows a user to input into the console. We then tell the user what to do. And then we just say scanner.nextInteger. So whatever the next int the user gives us, we're going to store it in user data. And then we're just going to print out whatever they put in. So let's run this program. If I enter the number 1, it's happy and the program exits. If I run it again, but give it the letter P, we can see we get an exception in thread main and we get an input mismatch exception. This right here is the stack trace. And if I click this link, it tells me exactly where it failed. So it tells me it failed right here on line 11. So just to drive the point home, the stack trace is Java's way of telling you exactly where the exception was thrown. That being said, it goes deeper than this. Let's refactor our code. So I'm going to highlight scanner.nextInt, and I'm going to right-click. I'm going to come down here, say refactor, and then I'm going to come up here and say extract method. It's now asking me for what do I want the name of my method to be. Get user data is fine. Now it did give me a primitive data type of int, but I'm storing it in big integer. So let's go ahead and change this to big integer. Anyway, when I rerun my program, and if I give it the letter P, notice our stack trace now has 2 blue links. So the first link tells us, okay, it failed on this line of code, but this line of code is referencing a method call. So if I click the second one, it tells me this is the exact line of code that it failed on. So if there are multiple nested methods, it will give you the whole rabbit hole and trace you all the way through the stack. Okay, so what is exception handling? This is when the software developer accounts for exceptions and tells Java what to do when an exception is thrown. So we don't want the program to stop running, we want it to fail gracefully. We do this with a try-catch block. So we have a try block, and then we catch an exception, and then a catch block. The try block is where we put the risky code, and the catch block is where we tell Java what to do if the exception is thrown. Okay, let's outline our try-catch block. We know that this is our risky code. So we're going to do try, then we're going to do catch. We're going to take our risky code, we're going to put it in our try block, and then notice down here it said an input mismatch exception was thrown, so that's what we want to account for. So that's what we're going to put right up here in our catch block. Input mismatch exception. This is something built into Java. I like to call my exceptions E, but I've also seen people call them EX, and I've also seen people call them exception. Any of those is fine. Now our syntax is a little broken. We still have a return statement here. So let's try this. Integer data is equal to scanner.nextInt, and then I'm going to return data. Notice this doesn't work. Java says, I can't resolve the symbol data. That's because data is not in scope. Basically, if an exception is thrown here, Java will not have access to this variable. So what we have to do is something a little bit different. We have to say integer data is equal to, and we don't have a value yet, so we're just going to set it to null. And then down here, all we're doing is reassignment. So we'll do something like this, where we say data is equal to scanner.nextInt. At this point, let's go ahead and just print out a message. Bro, you need to give me an int. So what happens is, when the user enters their data, Java is going to try to convert it to an integer. If it gets an input mismatch exception, it'll get thrown, but then it'll get caught right here, and then we'll print out, bro, you need to give me an int. At that point, it'll just keep running. So let's try it. So if I give it the letter P, it says, bro, you need to give me an int. Great. It also didn't print the stack trace, which is good, but it still didn't do what I wanted it to do. It said, you entered null. This is because data was null. It never got assigned to an integer because an exception was thrown. This null came all the way back up here, went into user data, and then we printed it out. Okay, so let's fix our code. So in the catch block, we need to try again. So we need to do scanner.nextLine. Basically, scanner stores the last value, so we have to throw it out. Then we can do this exact line again up here. If I rerun this, enter a number between 1 and 10. If I give it P, it says, bro, you need to give me an int, and now it asks me again. So if I give it 5, it's happy. Of course, you can see the downfall here. If I rerun this and say P, and then P again, it still throws an exception. So what do? We could have an infinite try catch block. Of course, that's not very practical, is it? So really, what we need is a while loop. So I'm just going to go ahead and refactor this. So we're going to say while true. And then I'm going to take our try catch block. I'm going to paste it in while true. Of course, this will keep executing infinitely, so we have to do one more thing. We need a break statement, so break. So if we actually get a good value into data, we will break out of our while loop, come down here, and then continue the execution. Of course, we also need to delete this line of code here, because it's already being handled up here in the try block. So delete. And now when I run this, I can keep going forever until I give it a good integer. Okay, here's another thing to note. Notice, even though an exception was thrown, we never printed the stack trace because it was properly caught. But let's say you need to, you're trying to do some debugging. What you can do is do e.print stack trace. So this exception right here, E, you can access a bunch of things, and one of them is the stack trace. You can also do e.getMessage. So let's run it now and see what happens. So now I do P, and the program keeps running successfully, so I can still try again, but it still printed out the stack trace for me. In this case, E didn't have a message, so there was no message to print. And I'm going to go ahead and delete both of these. So why would you print the stack trace? So the stack trace is automatically printed if the exception is not caught, but if you catch the exception, Java doesn't print it by default. So again, this might help you debug the code. That being said, you should not deploy this to production. This could expose file paths or data. This is for debugging and development only. Next up, let's cover throwing your own exception. So exceptions can be thrown by Java or by the developer, and we do this by saying throw new exception. So you may have noticed that there is a logical flaw in our program. Let's rerun. It says enter a number between 1 and 10. If I give it 11, it still works just fine. So we want to throw our own custom exception to say no, it's not between 1 and 10. So I'm going to come up here. So at this point, we got good data into our integer value, but now we want to check it. So if data is less than 1, or data is greater than 10, we're going to throw new, and we can throw any exception we want, but make sure to choose one that makes sense to someone else reading it. So illegal argument exception, that looks good to me. You can then pass in any message you want. So I'm going to say, bro, the number must be between 1 and 10. Let's just run this and see what happens. We're not done yet. So if I type in 12, we get an exception. And notice we get our own custom message. Here's the next thing to think about. You can catch your own custom exceptions. So I can catch another one. I can say catch, and I can do illegal argument exception. Again, I'm going to call it E. And then I'm going to do a similar format as I see up here. So I'm going to say print, but we already gave it a message up here. So I'm actually going to just do E dot get message. Then I'm going to do the same line of code here, scanner dot next line. This just clears the scanner and allows it to take in the next one. And when I run it, if I do 12, now it says, bro, the number must be between 1 and 10. I'll try another number. Okay, let me try to give it P again. It says, no, you need to give me an int. And so if I give it 4, it's happy. So now we're throwing our own exceptions, we're catching ones that are built into Java, and we're catching multiple exceptions. So now we have really good error handling. Next up, we do have a finally block. This is code that always executes. It is optional, so you don't have to include it in your try-catch, and typically you don't use this very often, but it is available to you. So if I come back to my code, I can do a finally, and let's just print out, I love you, bro. So when we run this, if I give it the letter P, it'll print out, I love you, bro, but also give me an int. If I give it the number 90, it'll say it must be between 1 and 10, but also I love you, bro. And then lastly, if we give it good data, it'll still print out, I love you, bro, and then it'll finish, you entered 1, and then exit the program. Next up, Java does allow you to catch multiple exceptions in one block. So you can catch an input mismatch exception, then use a vertical pipe, or catch an illegal argument exception and handle them in the same block. So let's say I didn't want to have two different messages here. What I could do is I could do vertical pipe. I'm then going to copy my illegal argument exception. I'm going to put it right here. Notice we do get a red squiggle. It says the exception has already been caught. So it's basically saying, listen, you don't need to catch this twice. I wouldn't know what to do. I'm going to go ahead and just click delete. Now be careful with your error messages, because this will catch if it's not an int or if it's the wrong size int. So instead, I'm going to give it a more generic message. I'm going to say, you gave me bad data. So now it'll say you gave me bad data, and you gave me bad data in both cases. Next up, we have custom exceptions. So Java lets you write your own exceptions. This is very helpful if you have a lot of custom code. So the way you do this is you say class myException extends the runtime exception, and then you can do whatever you want. So let's look at this exception. So throw new illegal argument exception. I want to make this into my own custom exception. So I'm going to come over here. I'm going to right click, new, Java class. If you scroll all the way down, you can see exception. So I'm going to say int too big or too small exception. Notice it automatically generates a class for you. It then automatically extends the runtime exception. So remember, this is inheritance. And then in its constructor, it calls the superconstructor. So it's calling the constructor from the runtime exception. So now, if I go down to main.java, instead of throwing an illegal argument exception, let's throw our own. Throw new int too big or too small exception. And then I'll pass in this string, just like before. And then make sure you catch it. So instead of an illegal argument exception, it's an int too big or too small exception. When I rerun this, it works the exact same. Now, if you really think about this though, do I need to pass in this message every single time I have an int too big or too small exception? Probably not. So I'm going to copy this. And when I come back to my class I just created, instead of taking in a message, let's just delete this. And let's just put the string right here. So now, anytime I have an int too big or too small exception, I don't have to pass anything in, and I can be assured that the message is always the same. So to see that message, I can come down here, I can do print e.getMessage. So if I give it 12, it says, bro, the number must be between 1 and 10, and I didn't have to define it every time. Okay, so how do exceptions work in real life? So remember, our goal is eventually to write code that runs on a server that's constantly spinning. So when an exception is thrown, we're going to send a message back to the UI saying, for example, the product price cannot be negative. Fix it and resend it to me. Eventually, we'll get to the Java Spring Boot framework in another course. It handles sending the message back to the UI for us, but it's built upon throwing and catching exceptions. So that's why you have to get good at understanding this. And just to drive the point home, remember back in our product class, we did something like this. We said set name, and we said, well, if the name is null or empty, that's invalid. So at that point, we just printed out invalid, and we returned. Okay, that's fine, but a better way to do this would have been to throw a new illegal argument exception and saying the product name is required. And notice, you don't need the return keyword, because when you throw an exception, it automatically jumps out of the method for you. Anyway, that covers exceptions. Go and do the homework. Good luck.